Let's start with our meetup. Hello and welcome everyone to the new Delhi SOLIDWORks user group third virtual meetup. I'm your host Sarvodaya Saksham and your user group leader. I'm a SolidWorks champion and a certified SolidWorks expert in mechanical design. Before moving further, let's discuss about what a SolidWorks user group network is. So the SolidWorks user group network is run for our user by our user. Its mission is to empower real people who use SolidWorks product to collaborate and learn from and teach each other. Right now, there are about 233 user group all across the globe with 18K plus member in it. These are the few benefits of attending a SolidWorks user group meetup. You have a chance to learn more about SolidWorks and SolidWorks related software. You have a chance to hear technical presentation that will provide you with valuable and real world SolidWorks tips, tricks, and technique. And the main benefit of attending a SolidWorks user group meetup is that you get a chance to win a SolidWorks giveaway. And in our in-person meetup, you have a chance to enjoy food and refreshment with like-minded individuals. Our today's topic is optimal hardware for SolidWorks. And to present this with us is Mr. Setzer. He's a technology evangelist at GSE with over 30 years of professional experience. And he loves teaching engineers, designers, and managers about new technology, tools, and technique. Now I would like Sir to present his screen. If anyone have any doubt in between the presentation, you can just message in the chat box or ask at the end when we have our open mic session.
Okay. Thank you very much, presenter.
You can present your screen also.
Okay, let's do that. And check audience. Okay, there we go. I'm going to then turn off my webcam here and go ahead and get started. Minimize this. Okay. So yeah, thank you for having me to speak with your user group. This is a presentation I've done for a few user groups over the years. I do maintain it and keep it up to date. It is, of course, in some ways ever changing, but in other ways it's pretty consistent. And I'll point that out as we go into the nature of how SolidWorks is architected and how it responds to different hardware, computer hardware out there. So what we're going to be talking about today is really the hardware itself, some things about operating system and some things about network and some technology, tools that you can use, have from a CAD administrator standpoint. This is not a discussion on SolidWorks settings, the tools options, system settings, or document properties. Those are great topics, but they're totally different discussions. This is not going to venture into any of that at all. So different people have had different experiences in the industry. As been noted, I've been with GSC for 30 years now, and but I've been using computers for a long time. And in grade school, this was the computer that we started with, this little Apple II back in the day. And my very first CAD system, if you can call it that, was something known as Turtle Graphics with a programming language called Logo. Basically, it was essentially you just told the little turtle, it was like a little pen on a plotter to pen up, pen down kind of thing, and then right turn, X number of degrees, and then go forward X number of units. And we could write little programs to do things like make little patterns like circles and stars and what have you. And that was back, I was probably, right around the late 70s when this happened. This computer, the Apple II, came out in 1977. Of course, if you want to save programs on a floppy disk, you had to wait a year. So it was a little more practical then. But this is for some of you, this may look familiar. For others, this may look like something out of an ancient history book. But this is my history of drawing on computers and designing on computers. Now today, we kind of break this down into 4 different areas with regard to SolidWorks: CPU, graphics, RAM, and local storage, which I used to call disk drives, but we really don't use disks anymore as such, although I may still slip into that old habit and terminology. To begin with, we're going to talk about the CPU. Now, this is actually the most important thing for a computer specification for SolidWorks. Generally because it's not upgradable, whether it's a desktop or a laptop. So whatever you get, you're going to be stuck with for the duration of having that computer. So it's important to get the right thing. Now, the general advice you'll hear out there is to get the fastest possible. But there's lots of varieties, lots of confusion out there with regard to the CPUs in general and how to read how fast they're going to be with respect to specifically SolidWorks. So the first thing we want to understand is that multiple cores do help in a few places in SolidWorks. You're opening up multiple documents, i.e. I'm opening up an assembly, and then therefore I'm opening up part files. That's multi-threaded. If I'm doing mass properties, body checks, combined / Boolean operations, those are multi-threaded. When I create drawing views, as I drop those views on a drawing sheet and SolidWorks does the hidden line calculations, those operations are multi-threaded. And simulation of various types, whether it's static linear, nonlinear, flow, those kind of things, those are multi-threaded to a point. So there are a few areas that multi-threading helps and multiple cores help. However, while it is true that most of our everyday software that we use is incredibly highly multi-threaded, like if you're using your iPhone or your Android or whatever, your Alexa, Siri, for them to understand your language, natural language processing, something that I did some work in the university. Yeah, that's massively parallel, and we're all very used to basically having software that's massively parallel. That's what enables us to do these things. But when it comes to SolidWorks or any kind of 3D CAD solid modeling system with features in it, especially, SolidWorks is largely single-threaded. This is key to understand when you're talking about what kind of CPU you should be getting for your next computer. So whether you're doing solving in sketches, whether you're doing features in the 3D model, whether you're doing mates, whether you're editing features, when you're doing rebuilds, which most people, when they think about it, rebuild is the thing they want to have be instantaneous and super fast. All these things, i.e. the vast majority of what SolidWorks is doing, from a computational standpoint, is single-threaded. Okay, cannot stress that enough. That is going to very specifically dictate what CPUs are best for SolidWorks. So if you're looking at a model today, I would say for a new computer, you want to have an Intel, the Core i7 12700, i.e. the 12th generation of the Core i7, 12700 or better. Now, what's better? How do we know that? Well, you can go ahead and look at cpubenchmark.com or cpubenchmark.net and these other places, and you can find these different benchmarks that are used to kind of rank these different CPUs in performance. And the general benchmark you're going to see at these websites is going to be some sort of pass mark or the CPU mark, which is going to be using all the cores on the CPU hardware itself, and then doing that benchmark there. That is not what you care about when it comes to SolidWorks. We just talked about the fact that SolidWorks is largely, almost completely single-threaded. So you don't care about the big orange numbers in the bottom here. What you care about are these numbers right here, the single-thread rating. That's the only thing really from a SolidWorks user standpoint that you care about. So if you're looking at, and these are relative, right? This is not like some absolute value of SolidWorks going X fast on a certain model. This is relatively speaking. So if I look at these things and I see the different models up there, so we have the previous generation, the 11700K versus the current generation 12700, the current generation is faster. Now, if I want to get the K model, which is the faster version of that, in the 12700K, that's even faster still, although not as much of a difference between those two as you might think in terms of pricing and availability, basically what it comes down to, especially these days. I'm going to get the 12700K. It's not that much more money than the 12700, but if I can't get it, 12700 will be fine. But I'm going to definitely get the 12th generation Core i7 and not the previous generation, even if it's got a supposedly higher core, because it's not just the clock speed, it's the core technology. Every generation is faster than the one before it. So single thread rating, I cannot stress that enough. If you learn nothing else this presentation, if you have no other takeaways, this is the thing I want you to all to take to heart and understand. All you care about, the only thing that matters really from a SolidWorks user standpoint for CPU is that single thread rating. That's what you care about. So when you look at that, and if you go to cpubenchmark.net, which is kind of my go-to, they have a specific listing for single threaded testing. So again, nice list, but it narrows it down to just the CPU Mark IV single thread performance, which again is what we care about, and that makes this list really easy to use. There's my Core i7 12700 baseline there, and then I can go ahead and see, well, the Core i9 12900F or the 12700K, or maybe some are higher i9s. Those are all there, again, depending on the price. Do I really want to pay more than double the cost to go from the baseline Core i7 12700 to a Core i9 12900KS? I mean, yeah, there's some speed there, but if I'm not doing really big stuff, the complicated stuff, do I need to worry about that? So again, single thread performance, whatever benchmark you're looking at, that's what you want to see. That's how you're going to compare relative from one CPU to another, and then take price and availability in consideration when you're looking at your next SolidWorks computer. Again, what about Xeons? Xeons of, again, a lot of confusion out there. Xeons, wow, Xeons are better than Intel Core. No, they're not, especially not for workstations. So if you're doing scientific computing, if you're doing specific applications, and I'm not talking about SolidWorks simulation either, I'm talking about specific other applications that really take advantage of high numbers of cores, then Xeons might help you. But you can see here very clearly that while the CPU general benchmark is much higher for that Xeon Platinum that we have listed, which by the way is street price of over $5,000 US versus $328 US, look at the single thread rating. It's a lot slower. It is much worse. You would be wasting an incredible amount of money if you got a new computer and you got that Xeon Platinum with that $5,000 CPU over the Core i7 12700 base that we're talking about. So I cannot stress enough how important the single thread rating is. That's the only thing you're going to care about in terms of SolidWorks use. So that actually makes that pretty simple. That's, as long as you understand that, you can go to compare any couple CPUs and just look at their single thread rating, whether it's the user benchmark CPU or it's whatever benchmark you want to use. As long as you use a single core rating, you got a nice relative comparison. Graphics also another area where there's a lot of confusion. So SolidWorks is a 3D CAD modeling tool, right? So graphics must be really important, and graphics are important, but for some things, not for other things. So the first thing I'm going to say is graphics cards. We're using a professional CAD system. It costs a lot of money. We're using it professionally to make money, or a company's making money with it. So go with graphics cards that have certifications at a professional level. Forget your game cards. Forget anything, that Radeons and that kind of stuff. Don't use those. Use the professional graphics that SolidWorks certifies on. That's what you want. Now that means that really we have essentially two lines available to us, and it's been this way for several years now. We basically have AMD's FireGL series and NVIDIA's used to be Quadro, and then Quadro RTX, and now just RTX series. So the professional OpenGL graphics cards from AMD and NVIDIA are what we're talking about here. And my preference has always been NVIDIA. I just feel that they're a little more focused less focused in the game world and more focused in the professional world. Could be either way. The current best general SolidWorks card for people that are doing, a lot of different things, small assemblies, but also larger assemblies, not just maybe even some bigger ones. That's doing some SolidWorks visualize, rendering occasionally. It's a general all-around card for about $1,000 US. That comes today, in today's thing, is the RTX A4000. However, most people doing, assemblies that aren't that many thousands of parts, that aren't really doing lots and lots of renderings in visualize, occasionally, but they're not banging out 100 renderings a day kind of thing. You can very easily get by with the A2000 RTX card. Now there are two versions of it. One that has 2 gig of video memory and one that has 6 gig. I would go with the 6 gig. You want to have that space. Again, is it much cheaper? $700 versus $1,100, $400? You know, that's why I kind of like the A4000. That's got a little more longevity in terms of scalability. But yeah, you can totally get it by with an A2000 without a problem for most casual, or I should say most mainstream SOLIDWORKS users doing mostly CAD and not tons and tons of rendering. Now, one of the things about that makes it difficult to kind of benchmark these in SOLIDWORKS or get benchmark information for SOLIDWORKS for these graphics cards, whether it's AMD or NVIDIA, is that they kind of like they'll run some tests, they'll publish some information, and then they'll stop. So the latest information, the last time NVIDIA did this was 2 generations ago with their Quadro P series of Pascal chips that they had. So they had the P1000, 2000, 4000, 5000. This is just for illustrative purposes only. But I want to also stress that this is for interactive graphics. The graphics card does not really impact your rebuild times. It is basically there to let you interact with your model. Zoom, pan, rotate. Or in the case of a 2D drawing, zoom and pan. It's not getting a new graphics card is not going to make your rebuilds go faster or anything like that, really. So essentially, you want to get enough graphics horsepower to do what you need, and you don't have to spend more money later on. So again, for SOLIDWORKS CAD, it's just navigation. When you look at this and put numbers on it, okay, yeah, if the P1000 or again, whatever, the A2000 is a certain baseline performance and you have relative performance, you look at, well, the P4000, P5000, yeah, they're maybe 1.5 times, or not even the P5000 is not twice as fast in terms of SOLIDWORKS models and frame rate for zoom and pan rotate, but it's way more expensive. So, you know, again, you have kind of diminishing returns here. Now, what we're really talking about here, we don't care about, in terms of graphics, we don't care about features, we don't care about numbers of parts. We care about essentially the graphics triangles that make up the 3D model. That's all that's involved here. So you can look at some models. These could be from imported IGES models. They could be SOLIDWORKS models. Doesn't matter. If you're just looking at the graphics triangles, and we see some various different ones from different people that have done these benchmarks. You can see the credits in the lower right there where we got these. So this thing is about 1.4 million graphics triangles, a little car. And again, these are older benchmarks, but this is what I can find. Okay. Basically, what we're saying here is that there's diminishing returns. Again, I have cards that are in the $500 range at the time, all the way up to $2,000 plus. And in terms of interactivity with SOLIDWORKS 3D models, there's really not much difference. Okay, so middle of the road kind of works out there. And then again, we're talking at the very top end, the 6,000 was way more, right, at the time. So larger assemblies, this is actually there is a high level, expert level Lego kit, the bricks of the London Bridge, and Dan Herzberg, a US-based SOLIDWORKS user, made the Lego bricks in SOLIDWORKS and put this thing together using all these Lego bricks. So there's a ton of graphics triangles in this thing. You can see here, it's like almost 41 million graphics triangles in this model. Again, to rotate, pan, zoom, looking at the frame rates, we're talking about first of all, they're all fine. They're all over 30 FPS for most modes. But again, we just look at the fact that in the mid-range card, the $400 card in that generation was just as fast as anything else. And again, you're talking about, instead of spending $5,000, you're talking about $400. So, but when you're talking about SOLIDWORKS Visualize, this is where things are different. So Visualize, this is the professional rendering tool that's part of SOLIDWORKS Professional and Premium. Visualize eats up GPUs as fast as it can. The more GPUs you have of a given generation of card versus one versus the other, the faster Visualize is going to render. It's almost a linear increase in performance. So then it becomes how fast you need to go and how much money you have to spend. So again, looking back at the 2 generations ago, which is the last time that NVIDIA put these numbers out for Solidworks Visualize, okay, you look and see we have the CPU is sort of the 1.0 benchmark, and then we have the P4000, 5000, all the way up here. And then some of these cards go up to, they're 18 times faster than the CPU in terms of rendering time. So that's a big deal if you're doing a lot of renderings. But again, you start putting money into this, start looking at real world, and there's a big jump going between the 5000 and the 6000, for example. And then, well, 2 P5000s is cheaper than 1 6000 in terms of speed. And again, this is NVIDIA's, this is what they published out there. So you might think that 2 P5000s is the way to go from a price performance standpoint, gets you almost 10 times performance of the CPU for rendering at a much lower cost than a single GP100 would have, for example, back in the day. However, what they don't show you on purpose is, well, the 5000 and 4000 singles are about the same performance in Visualize, yet the 5000 is almost twice as much as the 4000. So what they don't show you is what happens if you put 2 P4000s in the same machine, and well, you get almost the same performance as 2 P5000, except that you're paying, less than half the cost. So again, it's a moving target. New technologies come out every year. There are 2 generations newer than this. What that basically means is that you get the same performance for less money, or the same money, you get better performance. It's just how it works. Same with CPUs. So it's, that's where we talk about general, it's a little more squishy. I mean, with a CPU, again, single core performance, look at the benchmark. You have a hard number there, relatively speaking, from one to another. It's pretty easy to suss out. Graphics cards is a little more like, what do you really need? And then anything beyond that is going to be just money you don't necessarily need to spend. Again, in SolidWorks CAD, however, of course, rendering time, the faster you go, the more you can do, but it's a matter of how much money you got to spend. You look at a generation before that even, and I have the last two previous laptops compared to what I have now had these graphics cards in them. So I currently have a Dell M5540. Before that, I had a Dell M5520, which had an M4000 graphics card in it. And then before that, I had an old 3800, which had the K1100M graphics card. So you can see that going from one Dell laptop, these are the thin and light laptops, to do this rendering would take over an hour and 15 minutes. Same rendering, same pixel density, everything else. On a newer generation, took 13 minutes. And I can tell you now on my current laptop, this takes about 3 minutes. So again, it's not like I couldn't do the rendering with my old M3800 from the back in the day, but it would take much longer. So again, what does that mean to you? And if you haven't done any work with Visualize, these are some examples of things that I've done with Visualize. It's a lot of fun to use. Again, a lot of people have Visualize Standard because you have SolidWorks Pro or Premium. So it's something you can go ahead and just start working with and seeing if you have an application for it, it's right here. But you're gonna get the most bang for your buck for hiring graphics cards with Visualize. Now, again, depending on which version of SolidWorks you're using, we used to be based on OpenGL 2.0 forever, which didn't take really any kind of advantage on the newer graphics card technologies. In terms of, again, now I'm talking about just interactive performance. Zoom, pan, rotate your 3D models. That's all this is. But what we did in 2019 is we have a new graphics pipeline. It's an optional thing. You can turn it on or turn it off in system options. That is based on OpenGL 4.5, which is a much newer specification. It takes much better advantage of your hardware. Again, this is for interactive zoom, pan, rotate. That's what this is for. So if you start getting large models like this guy right here, where I have 26 million graphics triangles, 22,000 3D bodies, my old Dell 5520 actually had lower graphics, could could navigate this with the new graphics pipeline in 2019, whereas before that it would be just slow and almost impossible to zoom, pan, and rotate this model. It was just terrible. And as we go further on with my current Dell 5540 laptop, which has T2000 graphics, again, nothing like the RTX A2000 is way better than what I have in my laptop right now. Yet I could take that same model, put 3 of them in an upper level assembly, because all I'm doing is just graphics triangles. So I can open up an LDR mode, large line review, it doesn't matter. I just want to have the graphics on the screen. And you're looking at now almost 80 million graphics triangles. I turn the outlines on because that's how I like to work with my shaded models. And this is a little video I recorded of what that's like interactively. So basically I'm able to zoom. I can use a mouse wheel to zoom in or interactively zoom in with the shift middle button. And I can work with this model of 3 giant observatory buildings, basically. Again, 80 million graphics triangles very easily on what we would consider a thin and light laptop with some decent graphics, but nothing on the order of the RTX A2000 desktop graphics card. Okay, I'm going to go ahead and take a moment and look at the chat real quick. Will you send this slide after presentation? I'm not able to send this directly out, but I understand that the session is being recorded, so I think that can be. Oh, I see here. Yeah, it's going to be uploaded on YouTube. So there you go. Okay. All right. So let's talk about RAM now. Working task memory. I liken this to how big is your desktop versus how big is your file count. Your file count is local storage, which we'll talk about later, but the RAM is like how big is your desktop? How much stuff can you be working at the same time on your desktop, like in your physical desktop? So again, RAM used to be really expensive. If you've been around as long as I have, RAM used to be incredibly expensive per unit memory of the contemporary, whatever that unit memory was. Now it's very inexpensive. Now again, supply chain, COVID stuff changes this a little bit. RAM is sort of a commodity, and chips in general are a little hard to come by in some gross fits and spurts because of supply chain. But generally speaking, RAM is inexpensive, relatively speaking. And I would say, SolidWorks has, this sort of like the same thing as Microsoft. If you look and see what the minimum, specification to run their software, they got this like, yeah, you could do it, but it won't be fun for anybody kind of specification. I really am gonna one day, probably soon, change that to 32 gig of RAM being a bare minimum. But yes, 16 gig of RAM is the absolute bare minimum to run SolidWorks on like Windows 10 or 11. But you really need to have enough RAM for your largest data set and you're typically running applications. In other words, you need to have a desktop, a physical desk that's big enough to hold all of the papers that you're working on at the same time. You want stuff falling off, landing on the floor, or whatever. You want it to be big enough to handle all that. Yes, Windows is a virtual memory operating system like Unix and other systems are. So there's a swap file that stimulates RAM. However, it is an order of magnitude slower. You don't want to be relying on that in general at all. And again, you don't need to, because literally RAM is cheaper than dirt. Like again, locally in Wisconsin, state of Wisconsin, USA, in my part, I did this a few years ago where I basically said, okay, here's how much the 16 gig of RAM would be, $150. How much is XCR? Is a pile of dirt that you typically use to set up a garden, and the dirt was more expensive. So like literally cheaper than dirt. Now, how do you know how much RAM you need? Well, this is going to be in Windows 10. Most people are still on Windows 10. They're going to be for a while. We're modern version of SolidWorks only run on Windows 10 or now 11 as of this month with 2022 Service Pack 2. So basically, you go to the resource monitor, Control-Alt-Delete, resource monitor, right, in Windows. Then you have the tabs. You have the overview tab. You go to the memory tab. It'll show you all the applications you're running. And again, am I running SolidWorks only? No, I'm running Google Chrome. I'm running PowerPoint. I'm running Outlook because I have all that stuff loaded. Doing SolidWorks with my normal big, sort of biggest model that I'm going to work with to kind of get a high benchmark here, high measurement. And then I go ahead and look at this right here is what I'm looking at, the commit charge. The commit charge, roughly speaking, in Windows is how much physical memory you're using right now, plus how much additional physical memory Windows is allocating for the near future, is the best I can sort of say it, in the general terms. So at this point, this is what I want to see. I want to see this commit charge being in the lower half or halfway up. I don't want to see it too much higher than that. If it gets in the 80%, 90% used range, gets above this kind of line, then what can happen is Windows is taking things in and out of physical memory a lot, and that's where you can start getting instabilities and things like that. So I want to have plenty of breathing room. If I'm shopping for a physical desk or a workbench or something like that, I want to have it big enough so that it's not like when I'm doing all my work, it's fully loaded and crowded. I want to have plenty of space for moving things around, having some breathing room, having for a larger project, having some additional space for some additional capacity. I want to have that breathing room. That's the best way I can put it. So this is what you want to go for. Now this may be a little USA centric, an old TV show called Gomer Pyle. This is him saying, surprise, surprise, surprise. So something that people find very surprising when I tell them about this is that the way SolidWorks and again other CAD systems work, the video card onboard memory, i.e. the frame buffer, is mapped to SolidWorks active memory space that's using in RAM. So say you have only 16 gig of RAM on your computer, and you have some like really big, like an RTX A4000 graphics card on it, which has like 12 gig of RAM in it, of video RAM in it. When you run SolidWorks, it's going to map that into your physical RAM, and you're going to be left with only 4 gig of RAM for the rest of SolidWorks and everything else, Outlook, PowerPoint, the operating system that you're running. This manifests most often when someone takes an older computer, goes out and buys a higher end graphics card, sticks it in there, that older computer, and then when you're running SolidWorks, they immediately start getting all kinds of, you're low on resources type of messages, because this is what you're doing. So kind of the moral of the story is you scale the entire computer. You wouldn't take a small little compact economy car and go ahead and say, I'm going to upgrade it and put a V12 engine in it, and just bolt it the heck on there and let everything else be the same, because those tires, the transmission, the body, the chassis, none of that's going to fare very well because you're imbalanced. You have some big, huge thing upgraded, but the rest of it's not there to support it. So computers upgrade them or specify them as a balanced unit. So mostly what happens is if you're getting more higher end graphics cards to do like a lot of renderings and visualize, for example, you're going to need more RAM than you would need with SolidWorks, just because you have to handle the graphics frame buffer in the first place. And when I go to SolidWorks World or 3D Experience World every year, including this past year in virtual, I always sit in on our internal technical sessions. I verify that this is the case. It'll always be the case. This is the core way of how the software is architected. Okay, let's talk about local storage, i.e. disk drives, but they're not disks really anymore. And it's kind of amazing. I've lived this long. We've gone from audio cassette tape, open reel magnetic tape to this. Yes, okay, first of all, if you ask me what kind of storage you should have, it should definitely be an SSD, solid state drive for sure. Yet I'm also going to specify one thing further. Don't get an SSD drive on a SATA interface. This is the old style interface that, the last sort of disk specific interface we had. Don't do that. I mean, you can, but that's not what really is. And you can still find, especially desktops that have SSDs in a SATA enclosure and a SATA interface. That's slower. That's just them selling through old stuff. What you want to do is to have your SSD on the PCI Express 3.0 or later, basically that M.2 interface. This looks like a stick of chewing gum, essentially, with like a terabyte or half a terabyte of storage on it. It's kind of amazing. Again, this is me 30 years on here going, what have we come to? It's pretty incredible. but that's what you want. You want to have it. And again, most systems are going to have this. Any laptop, any workstation class laptop, or even consumer laptop is going to have this, because these are printing laptops first because of physical size and heat is much lower than a SATA. But yeah, this is what you want. And again, it's cheap. Half a terabyte for $80 US, right? So again, it may be a little fluctuating now, but in general, it's going to be much, much cheaper and much faster. So yeah, it's pretty simple. Now, in the real world, I keep this slide around. I've kept it around for almost over 20 years now. Back in the day, this is like what we were excited to pay $8,000 US for a machine like this. I just basically change the number of the years every time I do this. So yeah, I've been around longer than this. But in the last, SolidWorks era, this was sort of when I started doing this presentation back 20-some years ago. I keep this slide just to kind of keep track of and kind of contrast where we are. So this is $8,000 in 22 years ago dollars, by the way, US dollars. So this is much more expensive relative than what we have today. So an example desktop profile today, and I am a Dell person, but you can think of HP or Lenovo as well. You're talking about that baseline Core i7-12700, 64 gig of RAM, just kind of loaded up there, an RTX 84000 and a terabyte SSD. And you're looking at under $4,000 US in today's dollars. Again, that to me is incredible what we can do for that kind of money. Laptops, you definitely want to get a professional laptop if you can, because again, you can't upgrade the graphics card in the laptop. So you want to get that ZBook from HP or the Precision Mobile from Dell or the ThinkPad P as in professional series from Lenovo. That's what you want. It's going to have a mobile version of the AMD FireGL or the NVIDIA Quadro RTX. And again, just an example of current sort of what's out there. If you get, again, the CPU is going to be not as fast, but it's going to be, again, laptop light kind of version in terms of power and heat. It's still going to be pretty darn good. Again, you can look it up and see what the speed is, but you get that a good fast mobile core CPU. The same thing, 64 gig RAM and a terabyte of SSD storage, and then we're going to drop down to the A2000 RTX. Still very capable, and again, your laptop's more expensive. This is a thin and light laptop. It's still under $4,000 or $1,000 US. Now, in terms of operating system, again, in years past, it was a little more complicated. Now it's not. So I always have to have my old man, they call them dad jokes here in the US. How do you count to 11 using Microsoft's methodology? And there's the answer, right? So one of the things I always like to note is that the first shipping version of Windows was 1.01. It was a point release. And then, we kind of forget things like ME and 8.0 doesn't exist. Now we're up to 11. So these are all the versions of Windows as such. The first three were based on DOS even, or even their own operating systems. But that aside, okay, what are we talking about today? It's Windows 10 is really the standard. I mean, yes, we just brand new as of the SP 2.0 of 2022 SolidWorks, which is just out. Yeah, we do support Windows 11 going forward. Yes, we do. But if you're still running Windows 7, for example, you got to be running Windows 20 or SolidWorks 2020 and earlier. So again, it's kind of pretty solidified now. For now, it's Windows 10. That's the standard. And if you want to go into Windows 11, if you're on the latest version, an SP of SolidWorks, you can start doing that and have it be supported. What sometimes people forget is that SolidWorks also interacts with elements of Microsoft Office, in particular Excel, and Word, depending on what kind of what you're doing in SolidWorks for reports and what have you. But certainly, design tables are using Excel and rely on that. So yeah, you have to kind of keep up with your Microsoft Office too. Again, nothing too drastic, but some people kind of really stay on old versions of Office. So yeah, if you're on Office 2016 or or 2019, okay, even between those two, you have a year left before that's going to be unsupported. In terms of antivirus, antivirus used to be, SolidWorks would keep track of, or try to keep track of the versions of antivirus that they tested that could be tested to be turned on, and yet SolidWorks will still install cleanly, okay, because antivirus can interfere with the installation of any kind of software. Of course, they're in the knowledge base. If it had a problem with the installation, their recommendation would be turn off the antivirus and try it again. So, I always grew up in this industry saying turn off antivirus before you install any software, whether it's Microsoft Office, whether it's Adobe product, whether it's SolidWorks, whatever. I always turn it off. That's just how I always do it, and I still do it today. I will also point out that if you look at solidworks.com right now, and they're in this area where it has antivirus, it basically is blank. They just kind of gave up because there are so many different versions of antivirus software out there, not just the software itself and the companies, but the versions of them, and it just became impossible for SolidWorks to keep track of all that and test it all. So they just stopped testing. Antivirus can also impact your performance as you're using SolidWorks, because pretty much every antivirus software out there today defaults to real-time scanning of every file that you bring from disk to RAM. Now, if you're opening up a Microsoft Word document or Excel spreadsheet or a PowerPoint or something like that, it's not such a big deal because it's one or maybe a couple files that you're going to stop the process of writing to or being read from RAM onto disk, vice versa. But when you talk about SolidWorks models, especially assemblies that, you might have a 10,000 part assembly that references 6,000 unique documents. So what's going to happen is you have real-time scanning turned on. Every one of those 6,000 documents is going to be kind of intercepted by the antivirus software real-time scanning every time you open or save it, which can cause SolidWorks to wait a long time. Relatively speaking, the operation may happen, and then it can just give up and crash. So my recommendation, you're not going to be able to turn off real-time scanning on your system. No corporate entity is going to let you really do that today. But what you can do, all these antivirus softwares have some kind of an exception list to say, except for these files, scan everything in real time, all the time, except for these files. And what I would submit to you is the most low risk but performance enhancing way to do this is to have any file that has a .sld after it. So star.sld.star is the sort of file mask, which means SLD PRT, SLD ASM, SLD DRW, but also library files, SLD LFPs. That's also templates, anything in SolidWorks file. Now, am I guaranteeing you right now that no one ever is going to come up with a way to put a virus inside of a SolidWorks file and have it execute somehow when it's opened? I can't guarantee that. I'm just saying that the likelihood is very, very low, and you can really enhance your performance in SolidWorks file open and save if you exclude the actual SolidWorks files from the real-time scanning of your antivirus software. Certainly scan, if someone sends you a SolidWorks part from the internet or whatever, you FTP it or something, or they email it, certainly scan it, yeah, okay. But when you're talking about open and saving it, interactively, I would just have that turned off. I would just not do that. Now, where do you get the latest information? Well, SolidWorks system requirements. I have a QR code up there. You can scan that on your phone if you want to kind of bookmark that. This is where the latest information on system requirements and what's certified is going to be located. So what graphics cards, what drivers, all that kind of stuff. Operating system, Office versions, etc. Now, every time you add some real-time sort of scanning tool or some other widget running in your system that's doing some kind of task behind it, and it's not a SolidWorks thing, that's going to take resources away from SolidWorks. SolidWorks is the most intense, typically, be the most intense software you're running on your system. So if you want to maximize the performance, maximize the stability of SOLIDWORks, don't have a bunch of don't have internet radio running or streaming videos and music or whatever on that same machine. Do that on your phone or something like that. Try to keep especially on the network, try to keep things as clear and as open as you can, especially if you're really doing some heavy lifting in SOLIDWORks and they're doing some big stuff. Now, from a swap standpoint, I do have a little QR code link to an applicable Microsoft knowledge base article regarding the subject. Windows 10 is going to just do it itself if you don't tell it otherwise, and it almost never, in fact, I'll say never, it's never going to give it enough for SOLIDWORks. So again, you'll have these sort of occasional, hey, your system is running low on resources, and when you see that, one of two things is happening. Either A, you are way imbalanced in terms of video memory and physical memory, and or your swap file is not adequate to allow SOLIDWORks to do what it needs to do interactively. So again, this has been a rule that's been around for a long time, and I still find it to be relevant. You want to set your swap file size yourself. You want that swap file, the initial size, which is the amount of disk it's going to take off and use for. Windows will basically set that area aside as your swap file area, contiguous as much as it can. That's going to be twice the amount of RAM you have. Okay, so in my case, I have 64 gig of RAM. It's going to be 120 gig size file on disk. And then what I'll do is I'll set the maximum size a little bit above that, 10%, or it can be less than that. Basically, what I want to have happen is these numbers will be a little different, because if by some reason, and again, it shouldn't happen. For what I do, this should never happen. But if for some reason there's memory leaks, there's other stuff going on where Windows actually runs out of this contiguous swap file, it's going to go ahead and get the difference here interactively just on disk and just kind of try to keep the ship afloat before it crashes. And the important thing here is that if these numbers are different and it goes from here to here, if that ever happens, it's going to throw a dialog box on your screen saying, hey, you're very low on resources. You might want to close things and save things before you crash. If these numbers are the same, you will never get that warning. Again, you shouldn't even go anywhere near here. If you have enough physical memory and you double this, it should be totally fine. But again, I'm just putting that out there that I like to have this number a little bit bigger so that if for some reason things go really off the rails, I want to have that warning before it goes and starts grabbing extra disk space and, for the life raft, runs for the life raft before things crash. I want to know that. So that's what I do. Now, what about defragmentation? In the old days, we had spinning platter drives. That was a thing. You had to run some software, buy it, whatever. Windows 10 does it for you. Don't worry about it. Do not turn off for your SSD. Don't do that. Early in the SSD technology, they were using a different kind of memory that was lower life, essentially, in terms of how many writes and reads you could do. So people were concerned about it defragmenting being something that's going to lower the life of the SSD. Not a thing, not a problem. Just don't even worry about it. Literally, don't mess with it. Let Windows deal with it. Now, if you're in, especially, again, there's a little QR code here. You can locate 32 is a Windows application that I use a lot. I've been using it for decades. It's an old software, but it still works very well. Lets me find anything I need to find. Like, for example, I want to find every file on my system that has a little tilde in front of it, and it's going to be all these lock files. What happened here? Well, I was in SOLIDWORks in a big assembly, and SOLIDWORks crashed, which, software crashes, and then these lock files were not cleaned up, so that I have these all over my disk. So this is a tool I can use to do lots of things. It's very useful in general, but in this case, I use it to occasionally go ahead and find these tilde files on my system, and occasionally network too, and just kind of clean that stuff up. Because again, they're not harmless, but when you let this build up, okay, you're going to have tens of thousands of these things over years, and you don't want that. So just kind of, every once in a while, clean these things up. And again, the easy way to do that is a tool like Locate32. It makes it super easy. You can check your C drive, your D drive, your network drive, whatever, and then it'll find these all real fast. Basically, what it does is it makes a database. You let it update, and then it might take a few minutes. And then after that, everything you do inside here is on that internal database, so it works really well. You also use SOLIDWORKS RX to do some basic maintenance. This is a tool that's part of SOLIDWORKS, been that way for a while. There is a tab in it called System Maintenance where it knows things like your Windows backup directory and temp file directory, and you can basically have it clean these things up in these folders. But again, the files can be anywhere. So yeah, you can use this, but I still like to run my own checks occasionally and clean stuff up. RX can be used for other things as well, so you can see reliability. And literally, SOLIDWORKS will keep track of the last 30 days of opening it and closing the software, and it will record the status of did it close normally, did it terminate unexpectedly, or was there a fault? So terminate unexpectedly means Control-Delete. Someone decided to kill SOLIDWORKS for some reason. They were sick of waiting for something. There is the exception, which is fail exception, which is a real crash, and then there's a normal. So if you're a system administrator and someone's saying SOLIDWORKS is crashing like 5 times a day, you can actually verify that pretty easily in here. This is just part of how SOLIDWORKS works. Now, for over 10 years, we've had this SOLIDWORKS performance benchmark test. I find it to be a little dubious these days because, quite honestly, the models are not big enough to really challenge modern hardware. You don't get a whole lot of granularity if you run this test anymore. So I'd like to see like this thing pull up a 20,000 part assembly literally, and let's see what the numbers are on a machine, that kind of stuff. So yeah, it's there. Back in the day, I would say use it, but I don't really look at this too much anymore. I'm mostly looking at benchmarks these days. There's also a CAD Administrator dashboard in the when you log into the customer portal at SOLIDWORKS, where you get your knowledge base access, where you get access to your service pack downloads and things like that. There's a CAD Admin dashboard. If you are allowing SOLIDWORKS to feed back information anonymously to them, they will gather this information up for you, and you can actually see the relative results of benchmarks on one machine to another. Can be useful. This could be a whole separate presentation on how to use the CAD Admin dashboard. So just want to make you aware of it. Now networks. So basically we're talking about how fast SSDs are and RAM and all that kind of stuff. And networks are never as fast as anything in terms of local storage. Basically, networks can never be fast enough. So you want to have as much bandwidth as you can. And you also want to again, not have all kinds of other things competing for SOLIDWORKS with a bandwidth. Now, something that, again, this is a Microsoft thing. This came right out of one of their white papers. The way Windows handles a file going from a network drive to your local RAM, to your local system, is different depending on how you do it. So if I'm in SOLIDWORKS and I say file open and go across the network drive, then open the model from there, it's going to chop it up into much smaller pieces, okay, and it transmits it across the network. So it has more checksums that it can make sure things are coming across correctly. Versus if I go on to just Windows Explorer, navigate to the network drive and just do a copy paste to my C drive, when it does that, it's going to be a lot more less worried about it, and it's going to use bigger packet sizes, so it doesn't need as many checksums. Now, this file size is the same. In this case, it's a plain old Office document, and it's only half a meg, which is trivial, but again, a lot of Word documents are tiny. The difference is at the end of every packet, that little white line, that is where you have system lag, network lag. So if your network has 0 lag, it makes no difference the methodology you use. However, we all know that there is no such thing as a 0 lag network. So again, multiply this by much larger files. SOLIDWORks files are much bigger than 512K, and multiplied by an assembly that, again, maybe is only referencing 30 files or 150 files. You're still doing all this multiplication and the lag. So the best thing to do is to have your file copy locally and then open it from there versus going to file open in SOLIDWORks and navigate. It's going to go faster in general the way Windows handles the network traffic that way. Now, that's a pretty kind of arduous manual process to do unless you have something that's going to do it for you, which is where SOLIDWORks PDM comes in. Even PDM standard does this. Because if you're in SOLIDWORks PDM and you say check out an assembly, the first thing it's going to do behind the scenes is basically copy the assembly and all the related files from the network vault folder to your local hard drive in what we call the local vault view. And copy those over an operating system level copy, i.e. much less lag comes in to play. And then SOLIDWORks is basically told, okay, go get the file and open it, but it's from the local C drive. So mechanically, it's much, much better. There's all kinds of other things that PDM does, but from just from a performance, kind of the plumbing, how the network works, it's worth it just for that, in my opinion. People are more and more asking about virtual machines. Does SOLIDWORks support virtualization? Yes, but again, it's a moving target. It's not even published in terms of specifically what versions of these hypervisors, these virtual environments are going to be certified for 2022. You can bet they're going to be newer than what's for 2021. And then you still need to get graphics. SOLIDWORks is still a 3D graphics software, so you're not going to just use like a server with basic Intel on-chip graphics. You're going to need to get NVIDIA cards, like a grid card or something like that, and it has real GPUs in it, and then you're going to have to figure out, do you give them each their own GPU, or do you use a virtual GPU and split it up? But it's going to be one of these two situations. You're still going to have to put money, real graphics money, into that server to handle your users. At the end of the day, I don't recommend it. SOLIDWORks is, generally speaking, a desktop application. It's always been that way. It's been architected that way for 20 plus years. When you do virtualization, it is not less expensive. It is just different expensive. You spend money in different places. It adds complexity to your network, to your installation and upgrade situation. Still not going to be as fast as local, because you're going to be driving basically SOLIDWORks across the internet, and any kind of lag that's going to come into play is going to be more than zero lag, which is if you're just running SOLIDWORks locally and I want to click on a model and rotate, or right click on a face and get the pop-up menu, or do a feature. I'm not waiting for that lag. I click on something to go back to the server and come back and give you graphic feedback. If you want to try it, SOLIDWORks in a virtual setting, it's easy to do. If you go to my SOLIDWORks and you go to the try SOLIDWORks or try whatever, any of the trials, online product trials, that is SOLIDWORks in a basic and inside of a virtual workstation that SOLIDWORks DS maintains for this purpose. And you can try it and mess around with it, and you'll probably find out that it's like, oh, do you want to do this all day, every day? Probably not. It's good. It's good for a trial, but it's not like a product. We don't sell it that way for a lot of reasons. But if you want to try it, go ahead. Online product trial. It's going to basically be running SOLIDWORks in a virtual machine. Other necessities, other things that are useful, probably the biggest one are external hard drives. Because if you're someone who sets up your SOLIDWORks workstation, desktop or laptop, and you get all the settings and all the stuff all dialed in the way you want to, yeah, IT is going to have your basic system backed up. It's going to have all your SOLIDWORks files on a network server backed up, I'm sure, hopefully, right? So that's fine. But if your laptop gets run over by a truck and you get another laptop like the next day, you still have to like get everything back the way you had it, and that's time consuming. So little known fact, in Windows 10, or actually earlier, but Windows 10 has a built-in system backup that's an entire disk image. You can image your entire system just as part of Windows 10. And if you get yourself a cheapy USB hard drive, you can just do this at will. I do this once a week. So again, if my laptop gets stolen or fails or something, And my company gives you a laptop. It's going to have the baseline Windows on it. It's going to have that stuff. But all my settings, all my logins, all the other stuff, I'm going to have to reestablish myself anyway. So this way I can just say, you know what, give me the hardware. And yeah, it's going to have the baseline, but I'm just going to go ahead and restore from my backup. Yeah, it's going to take a couple hours. But then when I'm done, it's going to present me with the same login I've always had. And it's going to be just the way I always had it. So this is like a huge, to me, is a huge unused kind of bit of hardware for a Solidworks user, is to have an external hard drive and back your whole system up. Again, I'd say weekly. It's just, you hope you never have to use it, but when you do have to use it, it's very well worth it. Now, keeping up, again, I've done some QR code stuff. I would say, again, in GSC, we're the reseller. We have blogs, and it's international. Everybody can go there if they want to. SolidWorks, Microsoft. I would say that cpubenchmark.net, that's my go-to. You can use either one of these two, but I use this one just to check out, okay, currently, here's my crop of choices for my next machine from Dell or HP. This is what I'm getting in terms of choices. Which one is relatively fast in terms of the other one? And I look at how much it's going to cost me, and I can make my choice. So cpubenchmark.net is a place I go all the time. Again, GSC, my company's website, we've been around forever. We do blogs, technical blogs twice a week. And we have YouTube videos and things as well. You can hear the QR code there and go to it if you like. And that's kind of it. So kind of, again, summary, kind of keep your system clean, manage your software. Don't just be putting things on it that you don't need, because again, everything's going to take away from Solidworks performance. And if you're, again, sharing files, I would say use PDM. And again, we can even talk about another future thing. You can have someone do a presentation on 3D experience. Can't imagine anything that's going to let you share files globally, but work locally, which is going to be your fastest performance in terms of network hardware. And I'm on social media, our website. You can see all that information. If you want to contact me in any of those venues, you're free to do so. And that's all I have.
Thank you, sir, for this amazing presentation. And I really appreciate that you take your precious time, especially in that early in morning for you, 7:30 a.m. in Wisconsin, United States.
No worries. Not that early. It's all right.